Hey guys, welcome back. This is section 2 of the Pendant of Performance, and in this section we'll be talking about script execution. Script placement inside of your HTML files very much impacts performance, so let's take a closer look at how a browser actually retrieves and acts on the scripts that you place inside your HTML. When a browser tries to access a page, it's first going to send a request to the server for the document contained at whatever URL you're trying to get to. The server, of course, is going to find that document, hopefully, and pass it back to the browser. Then the browser begins to parse the document, and that's where things can get a little bit crazy on the performance side. The document could need any variety of important things that make a website, awesome, such as CSS style sheets, images, tons of images actually, and of course, scripts. Under normal circumstances, a modern browser is going to be able to download up to 6 components at the same time in what's called a parallel download. But when the browser finds a script to download in the page's code, all that parallel downloading halts. That's right, stops until the script is finished loading. This can mean super slow load times for your site sometimes. Now, where would we find such troubling scripts that have some sort of adverse impact on our performance? Well, any scripts that are high in the head or the body tags of your HTML page can potentially have a performance impact if they are not absolutely necessary, and even if they are absolutely necessary. So let's take a look at this website here. We've got the 3rd Regiments page, and right after that first heading you can see that script tag that looks for sparring.js inside of the 3rd Regiment's website. That seems harmless enough, right? We'll just get a quick download of it, and then we'll just get on with our lives. It'll be great. But what happens if that sparring.js file is processing tons of really time-consuming, data-intensive problems in order perhaps to make use of a bunch of data that's on the website? For example, could be building a huge array of soldiers from some separate file, could be calculating all of the possible unique groups for sparring groups of 2, sparring groups of 3, sparring groups of 4 out of all the knights. Whew, that's forever. Randomizes the order of those sparring groups if they're having some sparring day. Collects groups in pairs in order to have larger matches for whatever reason, and more processes, goes on forever, right? Now, while that script file is handling all of those data-intensive processes, everything after that script file, namely the rest of your HTML page, is going to stare at you. It's going to hang, and it's going to wait for all of that to be done. The result, of course, is poor load time and probably poor user experience. So we want to avoid that and figure out some ways that we can avoid it. Let's check it out. One great solution is to relocate all of those work-intensive scripts, because any script that's not really essential to the immediate loading and presentation of your web page should be moved as low as possible in your parsing of your HTML page so that that page can be present for the user immediately. Let's check it out. So what we'll do is we'll push up that paragraph to be right after the first heading, and we'll move the script down right before the end of the body tag, which is a great place for work-intensive scripts. Now, most of the visual information, all the other components of the site, that's going to become available for the user to check out while the data is being processed. Very valuable. A second short solution for this kind of problem is to use the HTML5 async attribute inside of your script tag, which will allow the rest of the page to load before the script actually runs. So let's examine that one too. So we'll push our paragraph back down, and we'll move our script back to its original location. Now what we're going to do is we're going to add an async attribute inside that tag, and that's going to prevent the script from blocking the page's load for the rest of the page. Now, we've got that async attribute dropped in there, but even though it's in the back here, you can put that async attribute as an attribute any place that you want inside your script tag. So what's going to happen now? Well, the browser is going to parse all of that initial HTML, and then it's going to reach the script tag, and it's going to say, oh, let's go get that script file. And then it runs to get the script file, but then sees the async tag and says, well, we need to load this script file at the same time as the rest of the HTML to be parsed on this page. This allows the rest of the document to get parsed, loaded, and ready for the user while any contents of the script file are being processed in the background. So async will give us much less of a processing time delay hit and can allow scripts that need to be high in the page to avoid hurting initial load time too much. Cool, so that's the end of this very short section on script execution. We're going to hand you off to some challenges, and then we'll see you back in the next section.